This part of 0005 is about logic, and logic is the formal study of reasoning, of arguments, of proof, and of truth or falsity. And we'll begin our study of logic with propositional calculus, which deals with propositions. So I better begin by telling you what a proposition is. And for us, here is the definition. A proposition is a mathematical statement which is either true or false. Let's look at some examples of propositions then. The first example here would be that this number, with lots of ones in it, is prime. That's a statement which is either true or false. I'm not telling you which, but it's certainly either true or false, so it's an example of a proposition. The next example is the statement that 34,043 is the sum of two square numbers. Again, this might be true or this might be false, but it's certainly one or the other. Next, 1 plus 1 equals 2, 1 plus 1 equals 3. Again, examples of propositions. And for the last two examples, we're going to look at some compound propositions where they're made up of two smaller propositions. So the first one is 25 is a square number and 26 is a square number. So you can see there that two smaller propositions have been combined using the word and into a bigger proposition. And for the final example, the square root of 57 is not rational, or the square root of 58 is not rational. And again, there are two propositions there which have been combined using the word or into a larger proposition. So perhaps it helps to give an example of something which is not a proposition. If I write a statement down like x plus 2 equals 7, well, you can't decide whether that's true or false because you don't know what this thing x is equal to. It's not in its own right a true or false statement because you need extra information to determine its truth or falsity. So propositions must either be true or be false. You can't require extra information to decide that. So as I said, our first part of 0005 logic is propositional calculus, and what that means is the study of mathematical propositions. It doesn't have anything to do with calculus in the sense of dy by dx. We're now going to look at logical connectives, and connectives let us build more complex propositions out of simpler ones. For example, they might modify an existing proposition, or they might let us combine two or more propositions into a compound proposition. The connectives that we're going to care about most of all in 0005 are and, or, implies, not. So let's look at some examples of propositions which are formed using these connectives. We'll have one example for each of the connectives. The first is the connective and, so we can form a statement like 343 is the sum of two squares and 343 is divisible by 17. You can see what's happened there is that two simpler propositions, namely this one and this one, have been combined using the connective and into a larger, more complicated proposition. Next, an example with or. 34,043 is the sum of two squares, or 3,443 is divisible by 17. Again, two simpler propositions have been combined using the connective or into a more complicated proposition. Next, not. It is not true that 34,043 is the sum of two squares. Again, this is a proposition. It might be true or it might be false, but it's a proposition which has been formed by using the connective not applied to a simpler proposition, namely that 34,043 is the sum of two squares. And the final connective, for which I'll give an example, is implies. So our example is that 34,043 is divisible by 3, implies 34,043 is odd. Again, it could be true, it could be false, but it's at least one of the two. Now in 0005 we will almost exclusively think about these four connectives. You might reasonably ask, are there any other connectives? Or you might even know examples of other connectives. For example, you might have seen the connective if and only if, or if with two F's for short. Or you might have seen things like exclusive or written XOR, or Sheffer stroke, or NAND, something like this. Now, those connectives exist, but we're not going to be particularly interested in them in the main part of 0005. And one of the good reasons, not why we're not interested in them so much, or why we won't focus on them, is that you can actually express these connectives in terms of the simpler connectives and, or, implies, and not. And in fact, you don't even need all four of those connectives, as we're going to see later on in 0005.